Hello, hi everyone. I'm Sukanya and I'm here to talk about my project. I work in the UK automotive industry analyzing dealer network performance for OEMs. So I built this project for Google 5-day AI agent course, and the problem I'm solving is a real one business problem. And when a manufacturer issues a recall, they need dealers to inspect and fix thousands of vehicles. But OEMs don't know which dealers have the technician capacity to handle it. They know where their dealers are, not whether they are already in 100% utilization. My agents solve that. They analyze workshop capacity across a UK dealer network and identify which sites can absorb recall volume and which are already overloaded. So, why I opted to agents? So, the reason I used agents rather than a single AI call is that this problem has natural stages. So, you need to validate the data first, and then analyze capacity, and then assess the risk, and then write the report. So, each of those is a different job. So, separating them in a four stages specialist agent means each one can reason deeply about its specific task, and you can trust the final output because the report writer is working from verified structured facts rather than the raw data. And I would like to walk through my architecture here. So this is a multi-agent pipeline, so using Gemini SDK, and with the automatic function calling, it's connected to the FastMCP. So there's a agent one, which is a data validator. It checks the data set is a complete before anything else runs. And there's a capacity analyst. It compares each dealer's utilization against a regional benchmark. And regional benchmarks matter here because Wales and Northern Irelands have very fewer dealers per capita, and so each site is expected to carry more load than one in England. So and then there is an agent three. Agent three is a risk assessor. So it ranks the most urgent sites by how far they are from their benchmark. And then there's a agent four is a report writer. It takes everything from the three previous agent runs and then produces a plain executive summary in English. And all four agents now share a set of tools through this fast MCP server, as I mentioned. So they list the dealers, they get the region benchmarks, and then they calculate the capacity status, and they get the regional summary and what are the top urgent dealers to be focused on. The agents call these autonomously using Gemini's automatic function calling. So they decide when to call uh, a tool and what to pass to it. And then I will walk you through the demo here on my Kaggle notebook. So let me go to the initial page. So this is the first cell installs packages. So we need Google Gemini and the FastMCP for the tool server. And you will also notice I have used Nest Asyncio. This is like just a one-liner, no, to keep the FastMCP run inside the Kaggle's event loop without crashing. And let me scroll down. So I've saved the output, but let me quickly walk through the code. So I'm just importing pandas here to access the data set, and then I'm walking through the data frame. Once it has written the list of dealers, it goes to get an regional benchmark across England, Scotland, Wales, and Northern Land, and it calculates the capacity status here, and then the regional summary. And once that's been done, it calls the top 10 urgent dealers to be focused. And then we need the MCP to read the autonomous agents. So, so I've done the agent one. So if you see, once the tools have been called, so agent one is a data validator layer, which checks all the data. And then I'm using the model Gemini 2.5 Flash. And then the data validator will call all the dealers, regional summary, and then gives a data brief, and that which feeds as a context to the capacity analyst. So it'll know what are the list of dealers by each region, how is the benchmark across each dealer, and then it feeds to the risk assessor what are the top dealers that needs this. So once this is all done, you can see a timeline. So if you see here, the agent one has been logging in when it starts, and then the region analysis, and then calling the benchmark. So if you come here, agent two is the benchmark, and then it can identify the top 10 dealers or the most three concerning, because the data set I'm using is only for 30 dealers. And then if you scroll down, you can see the risk assessor, which ranks the dealers by agency, and then a briefing. So what are the top 10 dealers? And then you get a final report, executive brief report. giving a specific recommendation for each dealer and a picture no by region. So all this is all is happening with just one call. No, the orchestrator just asks, you just get to ask one liner in a natural language and without any human running a query in between. So in the let's go back to the my write up. So I'm just using Gemini 2.5 Flash and FastMCP and Pandas and Kaggle data sets. This is a very clean one, like with MCP server, a clean separation layer. It never touches the CSV. It means it like can just you can just even change from a CSV to a live database without restructuring the agent code. And it has I've also not used any hard coded my API keys. I'm using the Kaggle's secret at runtime, and every agent call is logged. As you know, the timeline you can see when the agent one has finished and the one when does the next one start. And then I work in the UK automotive industry, and this is a genuine gap, no, where OEMs issue recalls without visibility into which dealers can actually process the work. So this agent pipeline is what proactively recall planning could look like, no, capacity planning. The same four-stage process like validating, analyzing, assessing, and report generation. It's been run as of now in a manual process, and this automates it. And thanks for watching. Thanks for the opportunity.